So a little bit of a quick review from yesterday. If we have something like 5x to the third plus 25x squared plus 30x over 15x to the third minus 60x I should just have there. And I ask you to reduce that fraction. I want you to take about a minute and see if you can reduce that in your notes. So to factor these, the top one, the first thing I'm going to do is I'm going to factor out a common factor of 5x, which will leave us with x squared plus 5x plus 6. And of course, that can factor further to be x plus 2, x plus 3. On bottom, I can actually factor out a 15x, leaving me with x squared minus 4. And that can factor further x plus 2, x minus 2. So now we can reduce the 5x and the 15x. Both can divide by 5x. So this will divide out completely. 15x divided by 5x gives me just a 3 there. Then beyond that, for the other pieces, we have to cancel out complete factors. X plus 2 cancels out. So as our result, on top, we have only x plus 3. And on bottom, we have 3 times x minus 2. We've reduced that fraction. So now the question comes, why is it that we were able to divide out part of this 15x, but we can't divide out part of any of the other factors? The reason for that is what we were really doing there was we were actually factoring the 15x into even smaller pieces. X plus 2 can't be factored into anything smaller. X minus 2 can't be factored into anything smaller. But 15x can be split into 5x times 3. So what we were doing was we actually were canceling out a complete factor of 5x. That's why we were left with a 3. Any questions on reducing fractions, algebraic fractions like that? So then the next step was to multiply. We had stuff like 7x to the third minus 63x over x squared minus 6x plus 9 times x squared plus 5x plus 6 over 7x plus 21. I'm going to give you a minute to do this one. Multiply those out and find a solution. So for this first one here, we're going to factor out the 7x. When we do that, we're left with x squared minus 9, which we're going to factor to x plus 3 and x minus 3. What's this bottom piece here factor to? That is x minus 3 and x minus 3. Good. That's a perfect square trinomial. What's this top piece here factor to? X plus 2, x plus 3. Good. I heard a couple of you come up with that one. And this bottom piece? Perfect. 7 times x plus 3. So let's look at what we can cancel out here. Actually, a lot of things we can cancel out. I have an x minus 3 and an x minus 3 I can cancel out. I've got an x plus 3 and an x plus 3 within that fraction. That fraction could be reduced. Now I have a 7. Now even though this is x plus 3, x minus 3, even though they're really close to the same, they are not the exact same, so we cannot cancel those out. So on top, we have x, x plus 3, and x plus 2. On bottom, we're left with simply x minus 3. So that is our result. On a test, I am okay with the answer left just like that. And I believe most of the time my math lab is okay with it that way. If you put down that answer and it says it's wrong on the first try, I would try to multiply this back out. You would get x to the third plus 5x squared plus 6x over x plus 3, or x minus 3. Anyway, one more example to review from yesterday. Two x squared minus 4x minus 6 over actually I got to change that a little bit. 2x squared minus 3. Yeah, minus 3x. Or minus, actually just minus x. Got to make up my mind. 2x squared minus x plus 6. That's what I get for not making my examples ahead of time, right? Over x squared minus 9 divided by 10x minus actually 10x plus 20. I'm going to have you do that division quick, and we'll talk about it in just a minute. So our first step, we have to change it into multiplying by the reciprocal. So the first fraction doesn't change at all. The second one gets flipped over. So it's x squared minus 4 over 10x plus 20. We factor this first one. I'm just going to do it above here to make it a little easier. 2x squared minus x minus 6 factors into what? I'd say 2x plus 3 and x minus 2. Because on the outside, 2x times negative 2x is negative 4. Or 2x times negative 2 is negative 4x. 3 times x is positive 3x. That's the negative 1x. On the bottom here, x squared minus 9 factors into what? X plus 3, x minus 3. Good. X squared minus 4 factors into x plus 2, x minus 2. And 10x plus 20? Perfect. We're just factoring out that common factor of 10. 10 times x plus 2. So now we need to, thanks, Ariana. Need to cancel out factors. We've got x plus 2 and x plus 2. It looks like we should be able to cancel out more, but because of the fact that we had the The division, we had to change that into reciprocal. That is all we can cancel out here. We're reducing that second factor. So this is 2x plus 3 times x minus 2 squared. Instead of doing x minus 2 times x minus 2, I'll just write x minus 2 squared over 10 times x plus 3 times x minus 3. And that is our result of that division. When we look at adding and subtracting, remember, whenever we add or subtract, we need to have the same name. For fractions, that was having a common denominator. In this case, both of those fractions are sevenths. Because they have the common denominator, we can go ahead and add them. And when we add them, we combine the counts. 3 plus 2 is 5, and we just keep the same name. So if I have fractions like 4y over 9x squared plus 8 over 9x squared, all I'm going to do is add the numerators. 4y plus 8 is simply 4y plus 8. And I'm going to keep that common denominator, 9x squared. Or we might have examples like 3x plus 7 over 5x cubed plus 2x minus 13 over 5x cubed. Again, we have the same denominator. We have the same name. So in that case, all we need to do is add. If I'm going to add 3x plus 7 plus 2x minus 13, what do I get? 5x minus 6. Good. 3x plus 2x is 5x. 7 plus negative 13 is negative 6. What's my denominator? 5x to the third. We simply keep that common denominator. Well, what if my denominators are slightly different? Let's say I have 7 over 4x plus 3 over 8x. I need to change them to have a common denominator. What do I need to do to give, what will that common denominator be? Put it that way. You got the right idea, but you're going in the wrong direction. There you go. It's going to be the larger one, the 8x. If you look at this, remember, common denominator is a common multiple, a least common multiple. So a multiple will always be bigger than or equal to each number. So it has to be at least as big as the largest of the two denominators. If I factor 4x, I get 2 times 2 times x. If I factor 8x, I get 2 times 2 times 2 times x. So what I need to make those the same is I need to multiply that 4x by another 2. Then they'll be identically the same, won't they? So I'm going to multiply this one, this fraction, by 2 on top and bottom. So instead of 7 over 4x, it's 14 over 8x. Now I have common denominators. I'm just going to do 14 plus 7 is 17 over 8x. Perfect. Something like this isn't quite as simple. I have 3y over 2x over, 3y over 4x plus 2y over 6x. Again, I can find those common denominators by factoring. What I'm going to do is I'm going to factor it right down here. 4 is 2 times 2, then we have the x. 6 is 2 times 3, and then we have the x. So what we're concerned about is what's different. So what I'm going to do is I'm just going to cross off what's the same. They both have a 2, so I can cross off a 2. They both have an x. I can cross off an x. What's left over tells us what we need in order to find a common denominator. This one has an extra 2, so I need to multiply this one by 2. This one has an extra 3, so I need to multiply the first fraction by 3 in the numerator and denominator. So this is going to become 9y over 12x plus, this is going to become 2y times 2 is 4y, 6x times 2 is 12x. We now have a common denominator. So we'll add 9y plus 4y gives us 13y over 12x. Can I change that to 1 and 1y over 12x? No. Remember, when there are variables in our fractions, there is no such thing as a mixed number. Even though this looks like it's an improper fraction, the 13 is bigger than the 12. It is not an improper fraction because we have no idea what the values of y and x are. Y could be very small and x could be very large, and therefore this would not be an improper fraction. It would still be a very proper fraction. So resist that temptation. Never break them down into mixed numbers if there are variables in them. Well, so far all we've had to do is adjust the numbers. What happens if we have to adjust the variables too? So let's say we've got 5 over 6x plus, or 5 over 6x squared plus 3 over 8x. If I factor 2x or 6x squared, I have 2 times 3 times x times x. That's my full factorization there. If I factor 8, 2 times 2 times 2, and then the x, of course, is just on the end. So once again, I don't care about what's the same. I care about what's different. So I'm going to cross off the pieces that are the same. I have a 2, and I have an x in each of them. Well, this one has a 3 and an x, which means I have to multiply this other fraction by 3 and x on the numerator and denominator. This one over here has a 2 and another 2, which is 4. And I have to multiply this one by 4 in the numerator and denominator. So that gives me 5 times 4 is 20. 6x squared times 4 is 24x squared for that first fraction. The second one here, 3 times 3x is 9x over 8x times 3x is 24x squared. We now have common denominators. We have the same name. So now we go ahead and add. We're going to simply add the numerators. What is 20 plus 9x? 9x plus 20 or 20 plus 9x, however you want to write it. Perfect. Over 24x squared. And yes, you are absolutely correct. Proper form, descending order, would require us to adjust that to be 9x plus 20 over 24x squared. My math lab is most likely going to want it in that form, in descending order, in the numerators and denominators. Any questions there so far?
I've been doing it kind of a little bit different. If I'm in the LCD, then I look at what I have to multiply the top one by to make it that, which is the same thing, only I'm not going through
The factoring?
all of that.
And that's fine. With the single numbers, what you can do, we did look at this, finding the least common multiple for two algebraic numbers. We looked at the numbers, 6 and 8, and we found their least common multiple to be 24, right? Then the largest power of the variable for multiples, so the largest power would be x squared, so that tells us it's 24x squared is our least common denominator. So yeah, once you get the 24x squared, you could go back here then and realize, okay, this just has to multiply by 4, so I do it on top and bottom. To turn 8x into 24x squared, I have to multiply by 3x. So that gives us the 3x to multiply by. Yep, that is just fine. The reason I'm doing the factoring is when we get to the more complex ones, the factoring is the way to kind of peel them apart. So let's have 7 over 10x squared y plus 5 over 6xy to the third. I want you first, I'm going to give you a half a minute or so, find the common denominator for me. Once you've found that, if you're done and I haven't started going over it yet, go ahead and start changing those fractions. So if we want to do it using that least common multiple method, we could do what's the least common multiple or least common denominator for 6 and 10? Should be 30, right? And then for our variables, we take the largest power. So for x, it'll be x squared. And for y, y to the third. So for this one, what do I have to multiply 10 by to get 30? 3. Do I have to do anything to the x squared? No. It's already x squared, so I don't have to change it. Do I have to do anything to the y? That'll be times y squared, right, to get from y to y squared. So I'm multiplying by 3y squared here. 7 times 3y squared is 21y squared. Over here, what do I have to do to 6 to turn it into a 30? Times 5. Do I have to do anything to the x? Times x to get from x to x squared. For the y, no, nothing to do. So I multiply by 5x there to get 25x. It would have been the same thing, by the way, if we would have done it factoring. This would be 2 times 5, x, x, and y. This would be 2 times 3, x, y, y, y. We cross out the 2's and an x and a y. Here we have 5x, so we multiplied by 5x over here. 3yy is 3y squared. That's where we got 3y squared from. So it works out the same. So now we have common denominators. What do we get for our result? Well, 21, perfect. 21y squared plus 25x is just 21y squared plus 25x. You ask about descending order there. Well, since they're different variables, it all depends on what variable you're focusing on. So really, it doesn't matter what order you put those in. And of course, that's going to be over 30x squared y to the third. Any questions there? So I'm going to have you guys try one in your notes. 7x minus 3 over 5x squared plus x squared plus 4 over 10x. Add those for me and see what you come up with. So what do you come up with for a common denominator? 10x squared, perfect. So this has to be multiplied by 2. So multiplying the numerator by 2 gives us 14x minus, has to be multiplied by, just by 2. So 14x minus 6. What's this have to be multiplied by? X. Good. So multiplying the top by x gives us x to the third plus 4x. Now what? Add the numerators. 14x minus 6 plus x to the third plus 4x. We've got x to the third plus, we combine 14x and 4x to get 18x minus 6 over 10x squared. How many of you had that one? Show of hands. Close? Okay. Any questions on how we got there? Okay, that's a start. Well, we can move up to the next step then into, things that might look like this. Working a little bit with finding those common denominators or changing the denominators. If I have 3x over 20 y squared, or y to the fifth z squared, and I want to change that to something over 60 y to the sixth z to the fifth, what's my new numerator going to be? Okay, perfect. This has to be multiplied, the 20 has to be multiplied by 3, so we're going to multiply by 3 on top. Y to the fifth has to be multiplied by y to make y to the sixth, so we multiply by y. Z squared has to be multiplied by z to the third to get from z squared to z to the fifth. So yeah, 3 times 3 is 9. Nothing to multiply the x, the y, and then the z to the third. So 9xy z to the third. Perfect. Well, how about something like this? If I wanted to rename this fraction from 3x over x plus 4 to something over x squared plus 7x plus 12. Well, looking at it, it's not quite obvious what we need to multiply this by, the x plus 4 by, to get x squared plus 7x plus 12. But if we go back to that strategy I used on the first few examples of factoring, it'll help. X squared plus 7x plus 12 factors to be what? X plus 4 and x plus 3. These both already have an x. What's that? That's exactly right. Perfect. They both already have an x plus 4. This left one needs to be multiplied by x plus 3. So that gives us what up here? 3x squared plus 9x. Perfect. We just distribute the 3x. So if I give you 5x over x minus 2, and I want it to become something over x to the third minus 4x. Tell me what that has to be.
Where you're going to be missing an x and an x plus 2.
Okay. So the x to the third minus 4x factors into x times x plus 2 and x minus 2. So yeah, they both have the x plus 2. This needs to be multiplied by x, and, or sorry, they both have the x minus 2, so this needs to be multiplied by x and x plus 2. So what does that give us? If I start out here, 5x times x is 5x squared. 5x squared times x is 5x to the third. 5x squared times 2 is 10x squared. So that's 5x to the third plus 10x squared over the x to the third minus 4x. So with that in mind, we can now look at fractions like this. 3x over x squared minus 25 plus 7x plus 2 over, oops, don't need the parentheses, x squared minus 6x plus 5. And when I look at these, to find the common denominator, I'm going to do factoring again. X squared minus 25 factors into what? Yes, it's the difference of perfect squares, so we get that sum and difference product, x plus 5, x minus 5. X squared minus 6x plus 5 factors into what? X minus 1 and x minus 5. So once again, we notice they both have the x plus 5. This one has an extra x minus 1. So we need to multiply here by x minus 1. This one has the extra x plus 5. We need to multiply here by x plus 5. Now to complete this, we actually do have to multiply this out so we can add. 3x times x minus 1 is 3x squared minus 3x. And that's going to be over x minus 1, x plus 5, x minus 5. Plus, over here, 7x plus 2 times x plus 5 is going to be 7x squared plus 37x plus 10. That's if I multiply those out doing the FOIL. That's what I should get. And on bottom, it's still going to be x minus 1, x plus 5, x minus 5. Now on top, I add 3x squared, 7x squared is 10x squared. Negative 3x and 37x is a positive 34x, and then negative 10. That is over x minus 1, x plus 5, x minus 5. We should be safe and try to factor that numerator if we can. To factor this, first thing we do is take out that common factor, which is 2. Can I factor what's left over? 5x squared plus 17x minus 5. Does that factor? I'll let you off the hook. It doesn't factor. So we cannot reduce this. This is our answer right here. Now we may run into examples that can be reduced, so you do have to be used to double checking to make sure that that numerator doesn't factor. I'm going to give you an example to try here. So 2x minus 3 over x squared plus 9x plus 20 over x plus 1 over x squared plus 5x. Try that one in your notes. Let's just make sure you've got them factored right. The first one, x squared plus 9x plus 20. What's that factor to become? X plus 5 and x plus 4. Good. X squared plus 5x is just x times x plus 5, right? So what do we need to do to this first fraction? Multiply by x. Good. So that's going to give us 2x squared minus 3x. What do we need to do this second fraction? Multiply by x plus 4. That's going to give us x squared plus 5x plus 4. This is going to be over x times x plus 4 times x plus 5 and x times x plus 4 times x plus 5. Did everybody get that far with it? Any questions on getting to that point? Okay. So now we've got 2x squared plus x squared is 3x squared. Negative 3x and 5x is a positive 2x and plus 4 over x times x plus 4 times x plus 5. We should try to factor this numerator, and I'm going to let you off the hook. It cannot be factored. I'm going to do a little foreshadowing. I'm jumping the gun on this by about 2 weeks. But how can you tell if a trinomial can be factored? So if it's of that form, ax squared plus bx plus c. If you take the square root of b squared minus 4 times a times c, if that is a whole number or an integer, it can be factored. If it's not an integer, it can't be factored. So here, if I'm looking at a, b, c, that'd be 2 squared minus 4 times 3 times 4. Well, 2 squared is just 4. 4 times 3 times 4 is 48. 4 minus 48 is a negative 44. We can't even take the square root of a negative at all. So that definitely cannot be factored. If it's a positive number in there, it actually can be factored. It just can't be factored with whole numbers, so we wouldn't be able to do it with the methods we already know. So it has to be a perfect square. Let's look at subtraction. Just like addition, subtraction has to have common denominator. So if I have 3x plus 2 over 6x squared minus x minus 5 over 9x. First thing I have to do is find that common denominator. So again, I'm going to give you about 20 seconds in your notes. Find the common denominator for the 6x squared and the 9x. What's our common denominator going to be? (18x squared). Perfect. For the 6 and the 9, the smallest number both of those go into is 18, and the larger power of our variable is x squared. So to get from 6 to 18, I multiply by 3. X squared is already there, so this first fraction is just multiplied by 3. What's that give me for the numerator? 9x plus 6. Good. What do we have to do to the 9x to turn it into 18x squared? Multiply by 2x. So we multiply by 2x up here. What's that give us? Perfect. 2x squared minus 10x. Now we are subtracting here. This is 9x plus 6. I'm going to have to put a 0x squared up here so that we can subtract 2x squared minus 10x. Put a plus 0 there. So 6 minus 0 is just still a positive 6. 9 minus a negative 10 is a positive 19x. 0 minus 2 is negative 2x squared over 18x squared. That's our result. We can move into bigger fractions just like we did with addition. We can have x plus 3 over x squared minus 2x minus 15 minus x minus 5 over x squared minus 25. To find our common denominators, as always, I'm going to do some factoring. X squared minus 2x minus 15 factors to be what? X and x, of course, for the x squared. What else? X plus 3 and x minus 5. Anybody have questions on where that factoring came from? Okay. X squared minus 25 factors to become x plus 5 and x minus 5. Good. Both have an x minus 5. So the first one needs to have the x plus 5. The second one needs to have the x plus 3. Multiply out those numerators. X plus 3 times x plus 5, x squared plus 8x plus 15. X minus 3 times x, or x minus 5 times x plus 3, x squared minus 2x minus 15. Oops. I had to put the x plus 5 down here as well, sorry. So x plus 5, x minus 5. Need the x plus 3 there too. When I subtract here, x squared minus x squared cancels out. What's 8x minus 2x? Or 8x minus a negative 2x, I should say. 10x. 15 minus a negative 15 is 30. Good. That's over x plus 5, x minus 5, x plus 3. Now, I told you we should always check to see if that numerator is factorable. Is this numerator factorable? Sure. Take out a 10, we got x plus 3 left over. Since that factors and one of those factors matches a factor in the denominator, that's telling us that this can be reduced. That x plus 3 can be taken out of there. So this is simplified to just 10 on top over x plus 5 times x minus 5. Some of you might have noticed I actually could have reduced this fraction. If I had reduced that fraction, it would have simplified the process from the beginning. I just wanted to show you that you can sometimes reduce at the very end like that. So it all comes down to factoring and matching up those denominators to get the common denominator. Now, one of the next steps we're going to work on is we're going to work on solving equations with rational expressions in them. In a simple form, we might run into something like this. 3x over 4 plus 5 over 6 equals 1/4. I could solve this equation just like it's written. I could make this 3/4 x plus 5/6 equals 1/4, and I could solve it. Or I could get rid of the fractions. What's my least common denominator for all those denominators? Well, I only have 4 and 6 are my only denominators. What would my least common denominator be for those? 12. So what I can do is I can multiply this whole equation by 12. If I do 12 times 3x over 4, the 12 and the 4 will cross cancel, give me 1 and 3. 3 times 3x is just 9x. If I do 12 times 5 sixths, 12 over 1 times 5 over 6. 6 and the 12 cross cancel, give me 1 over 2, or 1 and 2. 2 times 5 is just 10. Equals, if I multiply 12 times 1/4, 12 over 1 times 1 over 4. The 4 and the 12 cross cancel to give me 1 and 3. 3 times 1 is just 3. And now I can solve this equation like this with no fractions in it. What would I do from here? Subtract 10 to get 9x equals a negative 7, and then divide by 9 to get x equals negative 7 divided by 9 is just negative 7/9. And that's it. As I said, we could have just changed that slightly. Instead of 3x over 4 to be 3/4 x. And we could have solved it like this. In this form, the first step would have been to do what? We would subtract 5 sixths, yes. 1/4 minus 5 sixths would be a negative 7/12. And then we would divide by 3/4. Negative 7/12 divided by 3/4 is the same as negative 7/12 times the reciprocal 4 over 3, which is negative 7 over 9, which is the same answer. So because those denominators were numbers, it didn't matter whether we multiplied by that common denominator to get rid of the fractions, or if we just use the fractions. But we can run into problems like this. Eight over 3x plus 5 over 6 equals 7 over 2x. Plus, we'll go 1/3. What is our least common denominator here? We have 3x, 6, 2x, and 3. Well, for the numbers, 3, 6, and 2, what's our least common denominator there going to be? 6. And for the variable, it's always the highest power, so that'll just be x. So what that's telling us is we can multiply this whole equation by 6x. Now, for some people, it's easier not to use cross-canceling. If I do 6x times the 8 over 3x, I'll do 6x over 1 times 8 over 3x. For some people, it's easier to just say 6x times 8 is 48x. 1 times 3x is 3x. That divides to be just 16. (6x) times the 5 over 6. 6x over 1 times 5 over 6. 6x times 5 is 30x. 1 times 6 is 6. 30x divided by 6 is 5x. Equals. On the other side, we'll do 6x times 7 over 2x. So 6x over 1 times 7 over 2x. Now again, I could cross cancel. I could do the 6x and 2x both divide by 2x. But I'm going to multiply it out. 6x times 7x is 42x. 1 times 2x is 2x. 42x divided by 2x is 21. And finally, 6x times 1/3. 6x over 1 times 1 over 3. Like I said, I could cross cancel the 6 and the 3. But I'm going to go ahead and multiply it out. 6x times 1 is 6x. 1 times 3 is 3. 6x divided by 3 is 2x. And from here now I solve. What would I have to do to solve that equation from there? We usually start by getting the variable all on one side. So we'll subtract the 2x, giving us 16 plus 3x equals 21. And then? Now we'll go ahead and minus the 16, subtract 16. 3x equals 5. And then? Divide by 3. X equals 5/3 or 1 2/3. What do you think? Not so bad? It's just a lot to keep track of. Okay, rather than digging further... Oops, what's that?
My thing was trying to get out of greatest common factor into the least common denominator.
Yes. Yeah, greatest common factor for reducing the fractions where you use the lowest power, or for factoring where you use the lowest power of each variable, to least common denominator, least common multiple where you use the highest power of each variable. Yeah, there's a lot of people do struggle with that, going back and forth between greatest common factor and least common multiple or least common denominator. Okay, I think we've done enough damage for the week with these rational expressions. So even though we've got 8 minutes left, we're going to call her a day. So homework 8, A, B, and C. C, of course, covers the material we talked about today. But A, B, and C is the stuff for this week that should be done by Monday. I can't remember now if I posted it for Monday or if I posted it for a week from Monday. But I think I posted it for this Monday just because I figured nobody wants to sit there and do homework over spring break. But if you do want the extra time, let me know and I can extend those dates for you. Quiz 8, I believe I also put down as being due this Monday. But again, if you want the extra week, because we won't have class next Monday because of spring break, so I won't be able to answer questions. If you need that extra week, let me know and we'll extend it. So I won't see you next week because of spring break, so it'll be, what's it going to be? On the 25th, I'll see you again. You guys have a great break, and we'll see you later.